Thank you, Stephen, for being here. So you're going to give us some highlights about the second edition of the AI Safety International report. And it's quite a challenge for you, summarizing 300 pages of reports in 5 minutes. But I know we are in good hands, so if you'd like to start, and we'll be having this discussion afterwards. Thank you very much.
Thank you. Yeah, thank you for having me here. Fortunately, we've got the report down to about 200 pages this year, so this should actually be pretty easy. Yeah, I do only have 5 minutes to give an overview of updates in frontier capabilities, risks, emerging risks, and risk management. I'm not going to be able to cover everything, so instead I brought 5 sort of key updates that were really notable this year for me. We do have 2 key updates we published since the last report, and the next edition of the report with all new content is going to be released on February 3rd. So if you're interested in more, you can find those on our new website. But yeah, to just bring 5 key updates from the last year. The first is, since the first report came out last year, we've seen continued capability gains. So I looked it up this morning. Tomorrow is the first anniversary of OpenAI releasing O1 on ChatGPT. So we've had reasoning models around for less than a year still as of today, which is pretty remarkable if you consider all of the gains and developments that those models have brought over the past year. That includes continued improvements on various benchmarks. If you have an expert knowledge benchmark, the frontier models are basically crushing all of those benchmarks now, particularly in fields like math, coding, and autonomous operation. We've seen continued improvements over the last year. We've seen the models perform at gold medal level on the International Mathematical Olympiad this year. And in various cyber competitions, we're seeing more autonomous models compete with experts on exercises like capture the flag exercises. Those capability gains have been accompanied by diffusion continuing. So in the US at least, AI adoption is proceeding faster than previous technologies like the internet and personal computers. Hundreds of millions of people are now using AI chatbots and AI tools. This diffusion is very uneven globally, and in many parts of the world, particularly in lower income countries, adoption rates remain very low. But across countries like the US and most parts of Asia and Europe, we've seen very rapid adoption, one of the fastest growing technologies in history. We've also seen surveys of software developers where a majority of them now report using AI tools, and I'm sure basically every college essay is now written with chatbot help. And as a result, just over the course of the year, we've seen the frontier developers' revenue grow by billions of dollars. These continued capability gains have been accompanied in the past year by additional safeguards. So both Anthropic, OpenAI, and Google DeepMind released new models this year with additional safeguards after their sort of pre-deployment testing. The variations of this phrase appear in all the model cards, that they could not rule out the possibility that these models could assist novices with biological weapons development. And this prompted them to release these models with additional deployment and monitoring and refusal safeguards. That was an early test of these frontier AI safety frameworks. We've seen a doubling of companies that have released public frontier AI safety frameworks, which describe how they'll sort of introduce new safety and security measures as they develop more capable models. But we've also seen the limitations of those frameworks because we don't have a lot of visibility into how these decisions are actually being made, and there's not a lot of external validity of how those processes proceed internally or whether companies will maintain those commitments. In cyber, we've seen more documented use cases of AI systems assisting in cyber attacks, including by state-linked actors. These systems are not yet fully autonomous, and they still require a lot of human-in-the-loop assistance to launch these attacks. But there's many cases now of AI developers releasing information about these systems actually being used. However, we don't see an overall increase in the frequency or the severity of such attacks, and it's a little unclear why this is. And it's possible that the offense-defense balance is still unclear, and it's harder to track how these systems assist with defense as well. And finally, we've seen growing situational awareness. So models becoming more aware of being able to distinguish evaluation context from deployment context. Not all the time, only in a minority of cases, but in model cards now, if you look at the pre-deployment testing that companies are running on frontier models, it's now reliable that they will show situation risk. They'll be able to identify various evaluation contexts. We know this because, again, with reasoning models around for less than a year, we've only had access to the chain of thought, these sort of reasoning traces of models for a year, which has been a useful tool for safety and security. But it also shows that sort of our current paradigm of pre-deployment testing might be challenged if models are able to distinguish when they're in evaluation context and potentially adjust their behavior accordingly. So just to sum up with sort of a one-word finding, we've seen progress with limitations. And this is a graph that sort of demonstrates this idea in one particular case. This is from a red teaming exercise where teams of people tried to sort of prompt inject the models, so give them adversarial inputs that allow them to evade safeguards. And what you see is we're making progress. Like the success rate of prompt injection when you give these teams 10 tries is falling, but it's falling from it used to be 80, 90% success rates to now about half the time. So that's an improvement, but still about half the time, even the most powerful models with the best safeguards we have available can still be prompt injected if you give skilled people 10 tries. So that's the update for 2025, progress with limitations, and we have the full report coming out in February of next year.
Thank you. Thank you so much, Stephen. And yeah, it's great to have this kind of international report that allows us collectively to have a shared baseline to see how capabilities and safety risk are actually evolving throughout the time. So we're looking forward for the third version and then the fourth and so forth. So thank you very much for giving us those insights. And we'll be heading straight to the discussion of this great panel. I'm actually quite excited about this morning panel today. We have some great diversity of perspective, coming from research, industry, and of course AI Safety Institute. So yeah, without further ado, I'll do a brief and short and sweet, introduction of each one of you. Stephen, so Liam from Anthropic, you're lead policy communications and strategy at Anthropic. Helham Tabassi, you are a director of AI and emerging technologies initiative at the Brookings Institution. Matteo Pisillo, you are senior AI governance researchers at Apollo Research. And Andrew Strait, societal residence lead, UK AI Safety Institute. So thank you so much for being here. Absolutely, security. The name was changed. And I'm Yohann Ralle, EU Director at the Future Society. So maybe just reflecting on the International Safety Report, and maybe Liam, we should start with you. So the report was actually highlighting a growing number of risks. There was some mention of cyber attacks, and I know it's been quite an important concern for Anthropic. So how has Anthropic seen the landscape shift when it comes to evaluating real-world implications for frontier AI systems? And I think the emphasis on the real-world type of perspective you could bring in. When you are engaging with policymakers, what are the risks or incidents you are actually stressing out the most with them? Would be good.
Well, thanks so much for having me. It's a number of very big questions, so I'll do my best to try and boil it down. I think I spend an increasing amount of my time thinking a lot more about who I would like to do the thinking as much as what I would like them to be thinking. And what I mean by that is we're all a heavily engaged crowd of people who have an interest in the technology, and we also understand that it's going to have a big impact on pretty much every facet of our economy, society, and lives. And yet, the conversation broadly outside of this room is still at a lowish level, and there still isn't yet an appreciation of what is very rapidly coming down the track, particularly amongst political elites around the world. Some are a little bit savvier than others, but I'd say that the broad trend is one of one of like relatively low understanding. People sort of acknowledge that it's a big thing and it's something's going to happen, but they haven't quite internalized what that means yet. And that's partly a failure on sort of systems part, but I would say it's maybe a bit of a failure on our collective part, which is that it's a little bit more exciting to talk about the big grand risks, and it's a little less exciting to talk about the kind of now problems that exist. And I think we've sort of seen this big jump in public consciousness around things like cyber attacks in the last 12 months, but that's actually been something that's been a real prevalent problem for a much longer and sustained period of time. And it's starting to bite because big companies are experiencing it, and the government's having to be a backstop for potential losses, for example, with like JLR this year. And so one of the things I wonder, and it's a lesson, is that how much more can we focus on now problems to help ground people in understanding what the future problems might be, right? And that's not about making people more technically literate in the policymaking space. That's about understanding how they see the world and communicating in terms that they would get. And that's me talking as someone who was a political advisor for like 7 years and just knowing that that's how you have to ground things in order to get people to understand and then to act. As it speaks, I mean, what we've seen, I mean, the chart is quite interesting, right, is that the models are improving. Safeguards are becoming more effective, but people are just becoming more creative in terms of how to break them and to get them to do nefarious, novel things. What's critical there, I think, are two things. One, does the industry maintain its commitment to transparency? So does it keep talking about the difficult things as well as the good things? So I know from Anthropic's point of view, it's just sort of coded into the DNA. Is that like we are more than happy to talk about all the really uncomfortable things that we see existing in model behavior, as well as all the great things. But everyone else has to do the same thing too. It kind of like, it doesn't really work as an industry standard if like the race to the top is only being run by one company. Doesn't really work. And then the next bit on terms of global, like international level, multilateral level, I think it's hard to see things being formally structured, but what I do see when I travel around the world is there are still not enough countries that have set up things like the AC. And I think that like the UK has a best-in-class version of that. And I would love to see more of those institutions created by governments around the world, because it just gives policymakers highly competent technical overhead to engage with frontier laboratories who can then translate what is going on for policymakers and senior political leaders. And that translation piece is just incredibly important. Last thing I'll say before I wrap up and finish, because I know you want to go down the panel. A big part of the job is imagining futures, and those futures could come very quickly. But one of the problems is that we often kind of start with the technology and then build the world around it. And I just don't think that's particularly helpful. I think it's more interesting and probably more helpful and more efficacious to think about the different futures of the world existing and then the technology coming in at the end, actually, and then doing the process again. And so I made one point, I heard this very wonderful quote that someone gave at a speech in DC last month, and I'll steal it. But the person was talking about relative changes in economic value, which is something that has happened throughout all of human history. Expensive things become cheap, cheap things become expensive. This was lifted from Agatha Christie, and she wrote in a diary, I hope one day to be so rich that I can afford an automobile, but never so poor that I can't afford servants. And if you think about just like the relative economic value shift that occurred there, I think we're going to experience similar things as a result of the technology. And I don't know what they are, but they're definitely going to happen.
Thanks a lot, Liam. I wasn't expected to hear about Agatha Christie at this AI Athens Roundtable, but yeah, it's actually a nice quote. And I guess you're right about the Safety Institute. We need more of them. There is the Safety Network that is launching a dynamic, and there's a momentum, and a lot of countries are thinking about establishing their own AI Safety Institute or Security Institute. And I think we are on the right track for that. So it's a positive thing overall. Matteo, I'm turning it to you. I think it's actually a nice segue as you are assessing Anthropic models, among many others. And it would be good to get your views. We talked about risk coming from publicly deployed AI models. So, you know, the consumer-facing AI models that we're seeing currently. But I know that, you know, one of Apple's focus has been on internal deployment, where, you know, frontier labs are deploying models that haven't been released yet publicly, but are already operational internally. So do you think, you know, the internal use of AI labs is actually a blind spot in our policy and governance landscape today? Please.
Yeah, thanks for the great question, and thanks again a lot for having me here. Yeah, the short form is yes, absolutely. Ensuring that the systems that are deployed internally are safe and secure is probably one of the most important conversations that we should be having right now. And I will just frame why this is such a critical issue. So the systems and models that we're all familiar with, ChatGPT or Claude, Gemini, are all publicly deployed models. This means that they're essentially designed and intended to be accessible by the larger public. At the same time, there are other models that, for a variety of reasons, developers decide not to deploy externally and instead make accessible only by people working within the developer, within the company that developed them. And these models and systems can have many different uses, can be more or less capable, but there is one use that is particularly consequential, and that is automated AI R&D. Essentially, when an internal system is deployed within a company to automate the training of future generations of models and systems. Anthropic co-founder Jared Kaplan defined it a couple of days ago in an interview to The Guardian as the biggest decision yet. And I think that it is the biggest decision yet for two main reasons. And the first one is an opportunity. The opportunity is deploying systems internally for their use could potentially unlock recursive self-improvement, which means systems could improve future generations of systems that they are deployed to improve the next generation of systems. Now, something that you might have heard in the startup world is that there is some hype around 996, meaning working from 9 to 9, 6 days a week. Now, imagine an AI system that is a genius employee that works 0, 0, 0, midnight to midnight with 0 breaks. That's the idea. And the second one is a risk that is correlated with this recursive self-improvement, which is humanity might lose oversight over what's going on when the systems recursively self-improve. So we don't want that to happen. The main problem with recursive self-improvement is that organizations like Casey, the AI Security Institute, are doing excellent work on alignment, but alignment remains still a very much open problem. It is a scientific open problem. That means that essentially the systems that are deployed internally might in fact be misaligned. These systems, to train the next generation of systems, need affordances and permissions. So they need environmental resources to have influence on the real world. What does that mean? It means that they need access to hardware, they need access to code, they need permissions to read, write, execute, same way that human researchers do. So essentially, we have systems that are potentially misaligned, that have a lot of affordances and permissions, and might have little supervision. And that is a big risk that could potentially lead to loss of control. So at Apollo, we've been thinking extensively about this, and we suggested some solutions in a report that we published earlier this year. And some of the solutions that we thought are internal policies by frontier AI companies, whereby companies extend the scope of frontier safety policies to internal systems. And some companies already have done that. We also suggested internal usage policies that define who gets to use those systems and under what conditions. And then we also suggested an oversight framework. So essentially, who supervises this whole process and based on what conditions? One last consideration, and then I'll wrap up. It is really important that in this process, governments are situationally aware, and that's one of the greatest accomplishment of the International AI Safety Report is creating situational awareness for governments. So there are some ideas to make governments situationally aware of what is going on, and an example is sharing with selected government agencies, for example, AC, the results of pre-internal deployment testing, sharing those internal usage policies, and essentially create an important collaboration between industry and government.
Thanks a lot, Matteo. I think we do have a bit of time for a follow-up question. And just to ask you a simple question, as you know, you've been interacting with frontier labs, governance, research institutes. Yeah, can you share a bit of your insight on working with these different parties and how it has been working well for you? Yeah.
Yeah. Again, great question. Yeah, I think that I can think of two main trends. The first one is a lot is lost in translation between technical folks and people who think about policy and government stakeholders. And sometimes technical people talk about loss of control via misaligned systems engaging in scheming, and that message doesn't necessarily land with government stakeholders, but then government is very acquainted with the idea of national security, national level preparedness plans. And in fact, the two groups, the two communities are often talking about the same thing, just with different words. And I'm sure that it would be possible to bridge this gap. And the second trend is that I see a lot of growing convergence on goals and threat models. So, for example, loss of control was something that was not discussed as much, and now within government, and now it is appearing in legislation that has been introduced by Senator Ralle and Senator Blumenthal in the U.S. It appears in the code of practice. Another example is AR&D that I mentioned before. Now most frontier AI companies have capability thresholds for AI R&D, and that is also a capability that appeared in the code of practice. So it seems to me that there is growing convergence on where action is needed.
Thanks a lot, Matteo. Thanks to you, Yohann. And Matteo touched on, the need of a common language between policymakers, frontier labs, technical experts. And as for now, one of the shared indicators are benchmarks. But we all know that, most of them are gamed or saturated already. So I wanted to ask you a very direct question on what are the benchmarks out there that you are actually trusting to give you a sense of, evolving capabilities of frontier models. It would be good to get your views on that.
Yeah, thank you very much for having me here. Really great to be among friends and familiar faces and learn from all of you here. You used the word durability in your question, and you asked about the benchmarks. I think, as we heard on the summary of the International AI Safety Report, these benchmarks are saturating really quickly, and the data basically shows that their lifetime is quite short. Some of the tests that started in, for example, early 2024, for math, for some of the other tests. By mid-2025, they started with performance in single digit, and by mid-2025, the performance is in some cases 65%, some cases 90%. So these benchmarks get saturated really quickly, but that doesn't mean that we don't quite need them. I think there is still need for some sort of a baseline comparison, and basically because just doing this benchmark is difficult. But we are also seeing, getting to your question about what we look for, we are seeing some promising direction. So there are evaluations that try to sort of control the contaminations and limit the contaminations. The live benchmarks, live bench, live code bench, that are trying to kind of bringing the newer math problem, coding tasks, knowledge from archive and others, and try to update those tests. And I think a good governance is to also kind of add metadata of what type of questions, what data have been added. So this type of adaptive tests sort of expands the lifetime of the test, because then kind of prevent the contaminations, the tests actually seeing the data during its training. I think another trend is that this tests for human comparative with higher ceiling. I think Mader had started looking at performance of the AI agents for doing R&D, and those tests, even for the human to saturate them, is in terms of months, 8 months or so. So I think that's another one, and it's also relevant to some of the things that you mentioned. Again, on the summary at the beginning of this panel, there were results for example, more specific tests, the AI vulnerability, security. I think the more specific the test becomes, it makes the measurement easier. What's capability, what's reasoning. Math tests get the reasoning as the ability to solve the math problems, but is it really the reasoning? And there is a bunch of paper coming out and saying that the reasoning is not what you think as the reasoning is. And I think the last trend that I would say, and probably something that I like to see more, is sort of a process maturity framework that be able to assess the organizations for the comprehensiveness and robustness of the evaluations pipeline that they are doing, and by that comprehensiveness and the governance of that mission, some here that with the comprehensiveness of that, I mean that let's do the model testing, that's really important, but also be very careful and clear on the what actually we are measuring. As I said, capability reasoning sounds a little bit kind of conflated and open to different interpretation. Augment that with some robust stress testing, red teaming that can be adaptive, as we just talked about it, but also very important to get it with the field testing. So I think, and I think when we talk about durability, that probably is the most durable part, because how you document testing and evaluations that has this certain properties will age more gracefully than what's your score on that particular benchmark.
Yeah, absolutely. Thank you very much, Hallam. And as you were speaking, I was thinking, well, this all costs a lot of money actually to build up those benchmarks, to build up that AI safety and evaluation infrastructure. And we've seen, the last humanity exam, for example, took a lot of resources to develop and create. I'm thinking also about Gaia 2, which is quite a solid benchmark, but being developed by a frontier lab primarily. So do you feel, and this would be a super short question and a short answer, please, but do you feel like we are collectively putting enough resources into building up this AI safety infrastructure that we mostly need?
I spent almost all of my career so far in a measurement science agency, and I don't think we are doing enough on the measurement. And I think the biggest problem in the AI right now, you look at from any angle, it's the problem of the measurement. What we're measuring, how we're measuring, how we're documenting the test results.
Yeah.
So the answer is no, we're not.
Yeah, that's the answer I was looking for. So, perfect. Andrew, turning to you, Helen has actually mentioned, AI agents, and I know it's been quite a strong focus for the UK AZ. So, yeah, we're definitely moving from a world with AI chatbot to AI as an agent, taking control over computers, doing end-to-end tasks, text to action. So, how do we handle the accountability gap for this kind of systems?
Yeah, thanks so much. And before I get to your question about agents, I just want to kind of respond to a couple other comments from the panel and from the opening remarks today. Yeah. I think two things can be true at the same time. I think we can have a lot more to do around advancing AI security and safety, and also celebrate some of the incredible progress that's happened in the last few years. It's remarkable to me that we now have a growing number of national AI safety and security institutes that is only expanding in both of scope and geographic influence. It's remarkable to me that we have an international report that I, as someone in government, can point to help policymakers understand the kinds of risks these technologies might raise for their sector. It is remarkable to me that we have labs openly sharing aggregated usage data information through projects like Clio. I mean, that is truly, as speaking as someone who came from the tech industry, that is a very marked change, I think, in terms of the way in which some of these labs are thinking about safety, security, and taking it very seriously. And I think that this doesn't mean that we should pat ourselves on the back and say things are all great, right? There's so much more to do. And I think one of the things I'm really excited about over the course of this day is thinking through what those things are. I think we've got many ideas on the board, but I'm really keen for us to kind of drill deeper into what those specific proposals, actions, things we can take from this convening out into the ether are. The other thing I'll just say is one challenge I have for everyone in this room is to just think about, we really care in this room about AI safety and security. For most policymakers, for most policy teams, this is one of about 150 different things they are thinking about at any given time. So the language we use, to build on your point earlier, the kind of way in which we translate some of these issues into the ways that policymakers think about that, I think is of most crucial importance. And I can see great effort by my teams and AC to do that kind of work, but I think it's something that we just need to always think more about as we're kind of building a wider ecosystem, a wider field of this space, about how to translate those issues in ways that policy teams and government can understand. Okay, I'm not dodging your question, agents, I promise. I'm just, again, to remark about how crazy things are. Who would have thought that 2 years ago, we would have systems that are widely available in the hands of almost anyone who can execute complex computer-based tasks like financial transactions, cryptocurrency transactions, booking travel. That is something that in my wildest dreams when I was at DeepMind, I never could have imagined happening so quickly. And it's very exciting. There's wonderful opportunities that may bring. It also brings enormous risks that we are just still grappling with. And I think a few drivers of those risks that we're seeing are, one, the pace of capability, certainly. The fact that we're seeing wide capabilities so quickly advanced. But the second is the pace of adoption, the fact that those capabilities are so widely diffused through society. Again, capability, I think, is one thing, but adoption, both from a consumer and business-facing context, I think is one of the other significant drivers of how exposed we are to certain risks. One of the things our team tracks is where are agents being used, both in critical national infrastructure sectors like telecoms and energy, for what kinds of tasks, but also in consumer-facing contexts. And one of the things that project has highlighted for us is how we are going to have to constantly update our risk models for what kinds of risks agents may raise. So there's very obvious ones I think we've talked about earlier on cybersecurity. Are they robust? Can they be easily prompt injected? I'm very proud of the work that my team, mainly Xander Davies and Alex Sully, have been doing to work on testing those kinds of security vulnerabilities and finding ways in which we can patch them. But there's other challenges that, again, I just wouldn't have imagined. I mean, one project we ran was with a particular regulator where we tried to understand what systemic risk to the UK's economy might agents raise. And I never would have thought about this. It is kind of an important deal if an agent can open 10 bank accounts and then move money between them. Because if you can do that, that's all the ingredients you need for an automated bank run, a liquidity crisis, a huge issue. Now, thankfully, in our testing, we found agents at the moment aren't able of doing this, at least without intensive jailbreaking. Most of the major labs are blocking this kind of capability, and existing know your customer checks at banks that block the ability to create a fraudulent account are fairly robust, but we are testing those capabilities, testing KYC checks to ensure that they remain robust and resilient as AI capabilities become more advanced and more diffused. Now, that's a great example of a risk model that I don't think many of us would have thought about, but the only reason we discovered it is because we worked with other regulators, with other parts of government, in really intense risk modeling exercises to understand how might this capability, how might the wide diffusion, how might other factors around this technology change the way in which we think about AI risk. That is the kind of work we need to have scaled out very quickly at a much grander scale. And I'm very excited again by the fact that we have so many AI security institutes, safety institutes, a growing field of wonderful experts like everyone in this room who are working on those exact challenges. The last thing I'll just say, I think with agents in particular, is that there's an enormous challenge about measurement that these systems raise. Understanding what an agent is doing, why it is doing it, if it is accomplishing a task in the way in which it should be accomplished, not in some kind of crazy roundabout way, let alone how it's engaging with other agents out in the ecosystem, is an incredibly difficult challenge. We're just the foothills of understanding how to do that. There's incredible work by folks like Sash Kapoor, building the HAL pipeline, all these kinds of agent evaluations that I really want to credit. But I also want to caveat that I think this does beg the question of what kinds of data, what kinds of information do we need to improve evaluation science for agents. And that includes things like more access to usage data and agent logs. That includes things like more access to the kind of understanding of where agents are being deployed, in what contexts. It requires us understanding what kinds of tasks are we going to allow agents to automate, and crucially, which ones should we prevent them from using. It allows us to ask questions of what can websites or service operators do to prevent agentic actions that they don't want to take place on their platforms. These are some of the many challenges I think that we're facing in the year ahead. But if anything, the progress we've made in the last year makes me very optimistic about solving this. I genuinely think actually that this is something we all collectively, labs, the developers, governments, civil society groups, we all agree needs to improve and be addressed if we're going to ensure these technologies have maximum benefit and are used for the right use cases, and crucially that the risks we're so worried about in this room are managed and controlled. So I'm going to end on my optimistic note there, but I just really want to say I think there's so much work we can do in this next few days to really think through what those more specific actions we can take from building towards that kind of vision might be.
Thank you so much for that optimistic note and bringing that perspective. Yeah, my timekeepers are getting a bit nervous, so I think we are reaching toward the end of this panel, and I want to have to get some time to open up the questions to the audience. So I think I'll keep my follow-up question for now and just open up to the audience for some questions to our panelists, if you may. Nicolas? I think a mic is coming to you. Yeah.
To Matteo, so number one, great conversation. Well done, and well done to TFS for bringing this together. You point out the need to pay particular attention to the internal use of not yet deployed models. How about what we're seeing also at Prism Eval, the need to pay also attention to how models are used to evaluate other models, whether or not they are released, and how we can better understand the type of trust-building feedback loop between human and machine to scale up oversight, testing, and evaluation at model levels and obviously at agent levels. You want to share a few thoughts about that?
Thanks. Yes, absolutely. Great point. The underlying consideration here is once you automate R&D, you can automate both capability R&D, but you could also automate alignment research. You can automate testing. You can essentially deploy internally AI models and AI systems to both increase the capability pipeline, make training better and more effective, but also ensure safety, which ideally would be great because you could essentially scale safety and security capabilities much faster and at a much larger scale, but it still poses problem, as I was saying before, as long as systems are misaligned.
Paul, you want to ask a question?
Yes, I would like to ask a question on the weight you assign in these safety and security discussions to technical issues. All of you address technical issues as distinguished from, let's say, systemic issues of, incentives in capitalism or absence of civil law liability, insurance obligations, and so on. Why do I ask this question? Because in his book, The Cost of Accidents of 1970, Calabresi, the dean of the Yale Law School, analyzed how a society, namely America, can deal best with the accumulated costs of all the negative impacts of cars. Technology, accidents, how do we deal with it in society? And he developed a methodology how to deal with that rationally. And of course, one option is, build better cars, make them safer, and so on. But the other option is, and this is what the solution was at the time, obligatory car liability insurance. Everybody has to take it out. So that's why I'm asking you the question, is it right to jump in the spirit of technological solutionism on the theme we are discussing here, immediately only to technical criteria for the system's safety of AI and this and that? Shouldn't we have first a discussion on the higher level of abstraction and ask the question, what are the tools available to come to the goal which we are seeking, and then allocate the resources in our discussions in a little bit in the spirit of the speaker from the McGovern fund, saying, if we would invest the same effort in democracy and money as we do in AI technology, wouldn't that be a great world? So that would be my question to you. Wouldn't we come closer to safety and security if we first ask this question, and what is your answer to that? And where does the work stand in your organizations on this weighting issue?
I can try my best to answer this, Paul. This is a great question, and you always ask the hard ones. We think a lot about all the ways in which we need to mobilize, not just within government, but all the levers outside of government who need to be aware and understand of the risks that AI systems can bring and how to manage those risks. You mentioned insurance. One of the groups that we're working with right now through a project is insurance providers. We're trying to help understand what their current thinking is around the use of advanced AI systems in certain sectors, how they are factoring this into their insurance premiums and coverage, and really trying to think through what are they missing from the technical understanding of the use of AI in their sector. Now, we're not, again, our job as a research organization, our job is not to try to sort of tell insurance providers what to think, but it's really to understand how throughout all the different levers we have in society, all the different institution structures we have today, how are they currently responding to this moment? This is why my title is Societal Resilience. By resilience, we mean the ability not just to prevent harm, but also to prepare, absorb, understand, kind of mitigate as much as we can in all the other ways that may look like. And so one of the things that is currently happening is insurance providers, without us even raising the question, are already thinking about this. Moody & Porras has already kind of raised this challenge. Now, there's other levers that we're starting to pull. One of the ones that we're working with is on psychological harm, which is a growing issue and emerging risk. We're working currently with medical health professionals, crisis professionals, psychotherapists, to understand how therapists and their professional bodies are responding to this issue. What is it that they would like to see from the technology? How are they viewing some of the practices that labs are trying to put in place? Which, in general, I think, again, everyone is trying to respond to this issue, I think, with a really open heart and really trying to address a really enormous challenge. But it's a good way in which, as a safety institute, we don't just think of this as solely a technical challenge. A lot of what we're trying to do is understand what are the different organizations, bodies, institutions, levers that already exist in society that need to respond and react to this changing technology.
I sort of tried to touch on it at the end by saying we have a responsibility to imagine a set of futures, and we probably shouldn't begin with the technology and build out from there. We should just imagine the future and then see how the technology fits. I'll give you kind of 2 points on that, how I think it works. So one of the things I've been thinking about, generally speaking, is just crime and what motivates crime in the general highest level abstract, and a lot of it is profit, right? So like if you can make money, people will commit crimes in order to do it, and then you go down one level and you say, okay, fine, how is that going to play out in terms of the deployment of the technology and the ways that people can be very creative about extracting money and making profit. And then if you go one deeper, okay, where is that at the cutting edge and what's the tail? And so if you think about cyber, for example, the criminal end of the curve, right, is that's generally what the bleeding edge of technological capability. But if you go down like 6 to 9 months later, that's where information operations for foreign states are. And likely where cybercrime is now, in terms of its use of agentic systems and everything else, that's probably where your FEMI problems are going to be in about 12 months' time. And so there are a whole bunch, and none of that is like technical. That's just arcs of things. That's just like what is human behavior? What are incentives? A lot of what you're talking about actually is political as well. Because your question about liability, that's like how much do we all want to accept individually, and how much is socialized? Like that's a political question, not a technological question, and it should be above any industry.
Thank you so much, Liam. We are actually out of time, so I'll just wrap up by saying thank you all for coming here and bringing those great perspectives. I think, yeah, the common message has been around, raising the bar in terms of, societal resilient point of view, building up this AI safety and evaluation infrastructure that we mostly need, and you're all working towards that common goal. So thank you for that. And I think we can give a round of applause for our panelists.